Okay, welcome to part 2 of our Firebase tutorial series. This one's going to be on Firestore. I read your guys' comments about wanting to see the repo, so the tutorial is now on GitHub, on just my personal GitHub here, and I'm going to put a release every time I do a tutorial because I'm going to be committing a bunch to this as we do more different aspects of Firebase. So you can go to the releases and find the exact commit of this tutorial right here. Okay, so here's the lesson plan for the Firestore part 1. Firestore is a pretty big topic, so I'm going to do multiple videos just on Firestore. So in this one, what we're going to do is just explain what NoSQL is and the storage that we're going to use in Firestore. Then we're going to look at the collection, document collection kind of data structure that Firestore uses, and do both those just looking at the Firebase console. And then we're going to look at some code, the code being modeling the data in preparation for Firestore, meaning modeling out our user. I've done that in other tutorials, but do it again. And then we're going to make a Firestore repository so we can manipulate the documents to our create, read, update, destroy. And then we're going to use a block to connect everything together and make an app here. There's a couple things that I'm going to leave out of scope for this tutorial. One of them is querying. So you can do pretty complicated queries to get particular documents out. We're just going to get all or get one document and delete one. We're not going to do anything with the where clause in this tutorial, but we will get around to that at some point. Okay, so here is the Cloud Firestore section of Firebase, and here I am in my app in Firebase tutorial. And what we can see here is just browsing all of the documents and collections that we have. So Firestore uses NoSQL, which basically means documents of just JSON, and they're anything that you want them to be. So here I have one user with the user model that I've set up, and it's way more flexible than SQL because there's no rows and columns. You can just add whatever you want to anything. And not only that, you can have different things that are supposed to be users in the same collection with a completely different data structure, which is very flexible, but also quite brittle. So in your client, meaning your app, you're going to need to do some pretty hard work to validate and make sure that things that people are inserting to your Firestore are valid, because once it gets in there, if something has weird data, it might screw up the parsing of it later. So as you can see, if I wanted to, I could just delete this field entirely and it would let me, and there could be a different user that has that field and they would just both be sitting there. Or I could accidentally insert the wrong model entirely to users and put like a job or a location or something like that, and it would just let me. So the structure that we have here, actually let's look at what fields are allowed first. So in Firestore, what you're allowed: string, number, Boolean, map, array, null, timestamp, and these two I'm not going to go over. So you got your primitive types. Then you also have this timestamp field. So we're going to use a timestamp for our date of birth for our user. And timestamp is distinctly different from a date time. It is its own type, and the type is given to us in code as it's called a timestamp. So we're going to need to convert our date times to timestamp, which is a bit annoying. I don't know why they couldn't just use a normal ISO timestamp, but it is its own thing, and we're gonna have to convert to and from it. So I'll show you how to do that once we get into the code. So that's how it uses dates, and we could do a query later, such as born after 2020. You can use greater than or less than on timestamps and stuff like that. So yeah, one thing I've chosen to do is put the ID in the document, and it is also the ID of the document itself. So when you add a document, each document has an ID, and this is just a GUID. So you can go auto ID and it will just make you an ID. This is some sort of unique identifier. And then you can just start making stuff. We can make our fields and our values, and you can manually insert whatever you want in the console just as a starting point to test stuff out. So we can just go save. That makes ourselves a new document. And this is inside of the collection called users. So you can break out your documents into different collections, and then each document can also have collections of different documents. So you can see that this document that is in users has completely different data than our real user, and it doesn't care. That's completely allowed. And it could have another collection of something like favorites. Can't remember if there's a U in there or not. And then we can put something in here. Now we can see we got nested, right? So we went users, this is a collection, document, and then collection, and then document. And you can keep nesting and nesting and nesting. I can't remember the exact depth max, but I think it's outrageous. It's something like 20. Way more than you would probably want to use in practice, but it allows you to, of course. So let's go out here, and if you delete, there's buttons to delete stuff. Deleting the entire collection will delete both of these, and I think also this tab over here, but let's just delete this one document there. This will permanently delete all this data, including all nested data. It deletes that favorites as well if you do that here. So we go start delete, and when you're in the Firebase console, it ignores all rules. It just lets you do whatever you want. So you can set up permissions over here. We're going to do that again in a future tutorial. Right now I have it set so that anyone can read and write anything, which is good for development, but of course not appropriate for a whole production app. I think it would make most sense to start modeling out our user. So this is an example of what we're going to have. We're going to have the birth date, email, ID, email verified, name, and phone number. And none of this is real stuff. Of course, I just generated this with a random number of 42 and shoved in a bunch of strings. But let's look at the code now and the emulator here. Okay, so for the code, here's our user model. This is the model that we are going to be sending to Firestore and receiving, right? This is the data, but strongly typed. And for Firestore, what I like to do is put all of the keys that I'm going to use as static const on the class so that the name of the variable is not tied to the JSON key that it uses, right? Because if you don't have this JSON key name here, the name would just be ID, which it is. It happens to be the same, but this way we could rename something and it's not going to screw up our JSON. And we can also use these keys later for querying. So we're going to need access to know what these keys are in other places in our app. So yeah, this is just a model that we've seen before. We're going to have part and use the build runner to build us the actual JSON stuff. So we're going to go part user model.g.dart. And this one needs quite a bit more annotation than other ones because we're going to have, it's JSON serializable. I just put immutable there because your models should be immutable. Everything should be final or static const. And then we're going to also need this timestamp converter, which I wrote here. And we are going to look at that later, or next, I should say. Okay, so we got the ID, name, phone number, email verified, and birth date. So one thing to note here is that I have not made any of them nullable, right? So if somehow my Firestore got bad data, which it very easily could because it'll let you insert whatever you want, then this guy would fail to parse if it got something like an empty map or anything was missing at all. So just keep in mind, like, think really hard about what you want to be null or not, and put default values and handle things in the way that you need to handle them. I've just decided arbitrarily that none of these things could be null, and anything that's missing data is just going to fail to parse. So that's just a design choice, but you're going to have to think about it for the actual data that you're going to model. Because unlike SQL, where you can say this column can never be null and then it will fail to insert it, inserting valid JSON will always succeed in Firestore. It's just going to put anything you want in there. So yeah, we got our user model. This is just the constructor, and it can be const because it's immutable. And then we got these two functions here. This is a factory constructor to just call the generated method, which is going to be the from JSON, and then we're going to have the to JSON. So of course, when we're sending data to and from Firestore, it's going to be JSON, so we're going to need to and from JSON methods here. And then to generate these methods that start with the underscore $, we are going to run this command here, Flutter packages pub run build runner build, and then I like to use this flag so it regenerates everything, delete conflicting outputs. So that's going to generate these two methods, to and from JSON, which don't exist in this file. They're in the .g file. And then I've also just shoved some boilerplate on here, the equality and the hash values, which are nice for unit tests and just, yeah, if equality in general is quite nice to have on all of your models and anything immutable. Okay, so let's look again at how that timestamp converter works. So let's pay more attention to this birth date. Here I have it as a date time, right? That's a type that Dart has built in. But in actuality, what Firestore wants to be sent to it is a timestamp class. So let's look at timestamp converter. So this is a converter that I've made, and what you need to do to make your own custom converter for to and from JSON is use this JSON converter class, right? So it implements JSON converter, which means we need to give it to and from JSON, and it's going to change a date time into a timestamp to and from. So thankfully, it's very, very easy to convert from timestamp and date, because all you got to do is use the Firestore class, which is timestamp, and go to date. And then from to JSON, we just go from date, right? So we're going to receive, when we receive it from Firestore, we're going to receive a timestamp, but what we actually want in Dart is a date time. And when we send it, what we're going to have is a date, and then what Firestore actually wants is a timestamp. And it's unfortunate that this is a little confusing here, but once you put this converter on your models, you don't really need to think about it anymore at all. So to use a converter, once you've made it, you just need to put the annotation at the top of the file, and then when you run the command, it's going to know how to use that converter. And then when you open up the generated file, it's going to call your timestamp converter and use the to and from JSON on there. So that's how the birth date works, and it's a timestamp internally in Firestore, but again, a date time in our code. Okay, so that's the user model. And setting all this stuff up, it's a bit of work, but it's very, very important to have a to and from JSON for your user model, and we're going to see why in our repository for the next part. So the repository, this is an interface that is going to that we're going to implement for Firestore. What we're getting from Firestore when we get a document, it's called a document snapshot. And document snapshot has the ability to pass it in a generic type, and that generic type is T, and that's going to be our user model. And what it's going to do is it's going to do the to and from JSON for us whenever we get a document snapshot, as long as we pass those converters in. So in our user repository, we're going to implement these guys here, and that's going to be the bulk of the tutorial, is interacting with Firestore. So let's go to our repository and see how that's going to work. Oops, user repository, I mean. Okay, so we got our users repository, and it implements this repository, and then we're passing in that generic type of user model. So that's the type of model that we're going to be using, for our CRUD, create, read, update, destroy. And what we're going to need to do that is Firestore. Now, I basically get Firestore lazily, meaning I have a function that provides Firestore to me. I've used a type def here. So a Firebase Firestore provider is just a function with no inputs that returns me a Firebase Firestore. And the reason that I do that is so that in main, we can create all of our repositories with this firebase.firestore.instance, but we can do it in a way where we don't need to have Firestore initialized yet, right? So normally to go firebase.firestore.instance, what you need to do is await firestore.initialize app, and then you're able to use Firestore stuff. But when you do it this way, we can make all our repositories and set up our block providers, which we'll look at in more detail later, but we haven't called await initialize yet, and that allows us to do that in the splash screen and make it so that run app goes instantly and synchronously. We don't have to await anything at all. Right, so this is just a function, an anonymous function, that returns us that Firestore so that we can call it later. So in our user repository, this is what we're actually going to be interacting with. It's Firestore, and that's like a singleton type thing. Okay, so our collection name is going to be users. We saw that in the console. And now what we need to do to interact with that collection is we need what we call a collection reference. And the collection reference can also have that generic type of our user model. And this is where we're going to plug our converters in so that it's going to do all the to and from JSON stuff for us. And it's really, really nice. So what we're going to do is go firestore.collection and pass in that collection name. And then we have to add on this with converter. And this is where we pass in this model type, and that's the model that's going to have to and from JSON. So what we need to do is provide a from Firestore, right? So that's doing the from JSON, and then the to Firestore, which is just to JSON. So when you do this, when you have a document snapshot and you go .data, data, instead of being an object of just any type, it's going to be a user model, and it's going to strongly type that for us, which is going to be really convenient later. So we're going to see that we don't need to do any to or from JSON other than this once we set this up. So this is a collection that we're going to access all of our documents from, and our get and our queries and our add and delete and stuff like that. So let's look at one of the simplest methods, which is just get. get is basically just forwarding this call of string ID to collection.doc ID. So the way that I've set it up again, my user's documents, the user has the same ID as the document itself. So when I go doc.id, this is like a user ID, and then we just call .get, and .get returns us a future document snapshot, right? So when we're actually using this, it's going to be asynchronous, and we're going to have to await it to get the document snapshot out that we can actually interact with. Okay, so now let's go to get all. So I do have a warning here. Get all is very, very simple. We just get the entire collection and we await it and we return the documents. However, when you're actually using Firestore, you get charged per read. You get charged per write as well and per a lot of other things. But if you're returning every single document in a collection, that might become expensive. So just think about how big your collections are actually going to get. And if you have every single thing that 100,000 users are all interacting with all in one giant collection, and every single one of them is calling get all repeatedly, you might have millions upon millions of reads, and that could actually cost a significant amount of money. So in future tutorials, we're going to look at other things that have limits, so you can limit the number of documents, and we're also going to query in pagination. So you can also do queries where you go, get me the first 20, and then you say start at this document and now get me the next 20. We're not going to do that yet, but just so you know, this could get expensive depending on how many documents you actually expect to get in these collections. Okay, so now we're going to do upsert. So I like to use combine the idea of inserting and updating into one thing for Firestore, because it allows you to just write to anything no matter what. So no matter if this document exists or not, when we call set with a user model, it'll create it if it doesn't exist, or it'll update what's already there, which to me feels like an upsert, update, or insert if it's not there kind of action. And I think it just syncs well with the Firestore API. So maybe I should call this set, but I kind of like upsert. It's a funny word. But anyways, we just go collection.doc and we access it by ID. This is the ID of the document, which happens to be the same as the ID of my user. And then we're calling set with the user model. And then we just return get, and the set, is a void, so it does not return us anything. So if we want to see and make sure that the changes took effect as what we think, I like to return the most recent version. So this does make it 2 round trips, but I think it's a little nicer because then we know for sure we're getting the most up-to-date version of that Firestore document. So when you have your generic type set up, things like set, you'll notice it takes in a user model. We don't need to call to JSON. We don't need to do anything fancy here. All it needs is the model, and it knows how to go to JSON, which is really, really nice. It's super easy to use there. So, conceptually, we want to make this document a particular user model. We just go set and its user model, and that's all you got to do. Really, really nice. Query, again, we're not going to go over in this tutorial, but delete, we can see there's just a method called delete, and deleting, of course, you would probably want some sort of permission system set up, so you can't have users deleting literally the entire database or any other people's stuff, right? The way that you have it set up in sandbox mode, where you have no permissions and no rules, if the user got a handle on your Firebase and made a custom request that was just delete all collections, it would go through and it would delete everything. So in a future tutorial, we are going to go over the rules to make sure that your clients can't do that either inadvertently or on purpose. Like, you can't trust people. They might actually just try to delete all of your shit, which is terrible, but they might try. So we'll go over the rules later in a future tutorial. But yeah, any command on my Firestore will currently go through because I have the sandbox rules. Okay, so that's our users repository. Let's now go over using that in a block. So let's open up our block. So I had a request to make this block, instead of using a qubit, make our events into classes. And I think that's a great application here because these events are going to get a lot more complicated than the ones in other tutorials needing a lot more data. So containing all of that in a class, I think, makes a lot more sense. The more complicated your block is going to be, the more likely it is that you're probably going to want an entire class to represent an event opposed to just calling methods. It also allows us to split up all of the handling into different files, which makes our block really, really small, and it makes it really, really easy to digest the code, right? Like, how does deleting a user work? It's all right here, and it's only like 60 lines. So the first thing that I think we want to look at is this class I've made called process. So I was thinking in the previous tutorials, something that was happening a lot is tracking the idea of I'm making this API request, and maybe it's pending, maybe it succeeded, or maybe it failed. And I thought, well, why don't we just put that into a class so that we don't have everything split up into 3 variables, every single process, and now it's just in one class. So you can see here it's got a Boolean for loading, maybe there's an error message and it succeeded or failed, and then I've got some factory constructors for setting those flags, so .loading, .failed with an error message, .success, and .initial where nothing's happened, and then the boilerplate of the equality. So we're going to use that in the state. So let's look at our user state. So this is a state that's going to track all of the user documents that we have in our Firestore, or at least all of the ones that the app has loaded so far. So it's a map of ID and then the document snapshot with the user model. So if we want to get by ID, we'd access this map with the ID. Then we have some processes to track different states in our app. So the way I've got it set up is that you can load all of the users, you can create a new user, and you can delete multiple users at the same time if you spam the delete button. So the delete user processes are split up by the document ID in the process. And then there's just this little getter to map all of our documents in this map into the actual user models, because this is a lot easier for the UI to consume. So when you have a document snapshot and you want to get the actual data out, you just go .data, and that's a method. And if you have set it up with the generic types and the converters as I've shown you, .data will be the generic type you've passed it. So .data in my case is a user model. And then .data, it can be null because your document might not even exist. But in my case, I'm just using the exclamation mark. I'm just assuming that the documents that I'm using here do have data and they do exist. You can just make a document snapshot to a document that doesn't even exist yet. That is allowed, but I'm not going to do that. Okay, so we have an internal constructor because the only way that I think you should be able to manipulate this state is by copying it with different changes and just having a running, copy with over and over again as things change. So there is the initial state here though, and that means we have no users loaded. We have initial processes for everything, and this is just an empty map. And then this is how we're going to manipulate it with this copy with pattern. So this is the complete list of users, complete map of users, and then the new processes if those are changing. And then the boilerplate with the equality. So now we have our state to track our users. Let's look at the block. So our block, instead of extending qubit, in this case I'm going to extend block. And that means that I'm going to make a user's event class. This is an abstract class, and we're going to make all of our events inherent from that class. And then the state is just our user state. So our users block needs the repository, and this is the interface, right? The repository of user model. It's not the concrete one here, so that's going to be useful for mocking and testing later, and interface segregation as well. So the users block, it needs a repository, and then it needs to pass the initial state to the super constructor, just like the qubit. But what's different than the qubit is instead of just listing methods in this file, and this file grows to being hundreds and hundreds and hundreds of lines, all we got to do is basically just register each event with this on method. So on basically takes in an event type. You got to pass in this generic type of the event it's going to handle, and then you pass in a method that it's going to do to handle it, right? So whenever this block receives a user's load all event, it's going to run this method. And I've got it basically pointing to this method. This is my event handler, and my event handler needs the event, the current state, this method called emit, and then the repository. And that's the same for all of them. And in this tutorial, I think we should look at the load all event first. Okay, so this is just a method, right? It's just a top level function. It's really easy to unit test this sort of thing. I really like this pattern with using the block directly instead of the qubit for that reason. Okay, so our load all users needs the event that's incoming, the current state, this emitter, which is how we're going to output new states, and then the repository, because we're going to have to get those users. And it's going to be asynchronous and return us a future or void. So future or is either going to be a future of t or a t, but since it's void, it doesn't really matter too much. But anyways, the point is, we have this async method and we just got to implement loading all users. So to do that, we're going to do emit, just like with the qubit, and we're going to mark this process as loading. And we're going to do all of this within a try-catch so that we can have an error state. So the first thing that we do, no matter what, is mark the load users process as loading with the copy with. Then we're going to try to get all of the documents in the repository. Right, so get all, literally every document. If you have 1 million documents, it's going to try to read 1 million things. That could be expensive. So remember, this is a bit of just a learning experience. You probably don't want to normally get all documents. But either way, we got this list of document snapshot. And because our repository has this generic type of user model and that's passed all the way through, we know that our documents here have the generic type of a user model. So what we're going to do is copy the existing map of user documents from state, and we're going to manipulate the copy instead of directly modifying the state. So what we're going to do is just insert into the map every incoming document that we got. So user documents doc.id is assigned the document. So if one of them had changed, it would overwrite it. If it wasn't there, it would put a new entry in the map. And then assuming all of this succeeded without an exception, it's just going to emit a new state with all of those user documents and mark that process as succeeding. So this is all inside of a try-catch. And then if there's an error, we're going to debug print the error so that we can see what's going on. And then we're going to emit that it failed with the error. Now I have just directly put the exception in stack trace into this process here. If you had a real production app, you probably do not want to bleed raw exceptions and stack traces to your users. So this would probably want to go through some sort of error formatter. But again, just as a tutorial, we're just putting that string directly in there. It's just the raw exception that we as developers want to see. So you could update that later once you want to display a specific error message to a user. Okay, so let's load all users. Let's look at another one. Let's look at create. So create user has pretty much the same function signature, except it's a user's create event. And it's going to have the same sort of stuff, the state, the emit, and the repository. So first off, just like the other one, we're going to emit that this process is loading. And because they're different processes and the copy with isn't modifying anything else, you could do multiple things asynchronously and it would work totally just fine, right? You could create a user at the exact same time that you're loading the full list, and it's all just going to work out due to the block sorting it out for you with its event handling. Okay, so what we're going to do is make the user here, and we're going to create the ID on the client. Now you could just let Firestore sort out what document IDs it wants to have. I've just chosen as a design choice to use this UUID plugin and make ourselves a unique identifier for all the users and choose the document ID myself. You could just let it auto increment for you, but I kind of like to do it this way. So the event has all the properties that we need to create a user. So we haven't actually looked at the events yet, so let's just look at all the events in general. So we have an abstract class that is a user's event. Every single one of these events is immutable, and all of them inherit from this base event class because that is the event type that this block wants to handle. Okay, so we looked at the user's load all event. Some of the events that are going to be simpler might not have any parameters at all, right? If we want to load all users, we don't need to know anything else. We don't need to know anything about a query or whatever, so it doesn't have any parameters at all. And then the user delete event just takes in an ID, and then the create event has the most data. It has some of the properties that a user would have, but some of it is also hidden from the UI later, right? So remember, block is about business logic, And logic is something like choosing the ID and knowing whether the server or the client is choosing the ID of new objects. That's not something that you want your UI to do. And your UI is what's going to be dispatching these events, right? So the idea of IDs and how those are created is encapsulated inside the block because that's business logic. So I've just defaulted them to not having their email verified. Again, this is just a pretty bare bones tutorial. This doesn't actually ever do anything, but it's just there as an example, as a Boolean. So we're going to go and await our upsert here from our repository, and that's going to return us the user document that it creates. And then we're going to, again, copy the map of existing documents and just say the document of this user ID is the one that we just created. And then we're just going to emit that that worked. So we're just going to emit with the new user documents, and we're going to say that the create user process succeeded. And then on the error, all the errors are going to be identical. It's just going to make this gross string, debug print it, and emit that it failed with the correct process. The only one that's a little bit different for the error actually is the delete user. So let's look at the delete user now. So the delete user takes a delete event that just has an ID on it of the user that we're trying to delete. This one's a bit different because the processes to delete are also broken up by ID. So we need to also copy the processes and then mark the specific user that we're trying to delete as loading, right? So this is the user ID and the document ID. And then we're going to emit that map is changed. And this is like our marking with loading like in the other ones, except this one is split up by ID. So we're going to likewise copy off our user documents, and then we're going to delete the users. Actually, I've made a mistake here. This should definitely be below the delete. So the reason that should have been below the delete is that you want to copy the map and emit it synchronously right after. So let's say hypothetically I left that where it was above. What happens if asynchronously a whole bunch of delete events come at the same time? What's going to happen is it's going to copy all of the maps a bunch of times, and then it's going to call delete, and then they're all going to finish, and they're going to have like the wrong copy of the map because after they've awaited and something has changed, they're going to have that old copy of the map. They're not going to have the new one, right? So you can imagine if something asynchronously happened, asynchronously somewhere else, like another delete event that also modified this or loaded, they're going to have an out-of-date version if that's not right after the await. So I'll commit that and update the commit that's on the release version there. But yeah, I hope that was instructive either way. So we're going to copy the user documents, remove the one that we deleted from our local state, and mark the process as succeeded. And similar thing with the delete, except again, the delete processes are in a map. So we're just going to mark that specific one as failed. Okay. So now that we've looked at our block and the event handling, let's take a look at the UI that I've made apart from the querying. We're going to do queries in another one. So yeah, let's look at main first. So we looked at main a little bit. This is where we're making our user repository, and then we're calling run app. And just like in the other block tutorials, we're going to need to provide that block to the app so that block builders can look up our block and build their themselves based on the state of that block. Now, we're definitely going to add more blocks here in the future because this is just users, so maybe we're going to have another block for files or for whatever comes up out of future tutorials. So I've just started with a MultiBlocProvider even though there's only one, so that we can put a bunch of blocks here. So yeah, this block provider just provides us a users block, and the users block needs the repository. Okay, and that wraps the entire material app. So everything in the app is going to be able to use a block builder with that users block. It's effectively like a global or singleton type thing. Then in our splash screen is where we are actually calling initialize app. And only once that's done, we are going to navigate away from this screen. So what we're doing in init state of the splash screen is we're calling init app. And then once that's done, we are pushing the route to the home screen. So I have left this under the assumption that we're going to add more here later, like something like Firebase auth, and checking whether or not your user is logged in might take enough time that we want to have a splash screen in general. So this variable is not used yet, and we're not doing anything else here yet, so it is pretty much instant, but it might not be in the future. So I've set it up so we can expand on it later. Okay, and then yeah, we go to the home screen. The home screen is the screen that we're currently viewing. So I think what I'm going to do is make a list tile which has a on tap to go to each segment of the tutorial. So this one is going to take us to the user screen, and then later when we have some more stuff, we might get some more list tiles in here. So yeah, we're going to tap that and go to the users screen. Okay, so the user screen is wrapped with a block builder, and that block builder has the user's block and the user's state. When you pass these generic types in, it knows how to look up via build context the closest enclosing user's block that is provided to the app, which is around our entire material app. So it's going to catch that one block that we've provided there. And then it's going to give us the ability to build our screen based on the state of that block. The reason that I put it around the entire scaffold is so that the app bar has access to it. Because with the app bar, if you only put it around the body, then the app bar wouldn't have access to this, and we want it to because, sorry, not just the app bar, but the floating action buttons down here. Okay. So first, let's look at the floating action buttons and how we're going to dispatch events, or actually the load button. Sorry, I just jumped around a little bit, but we're in the body of the scaffold, and we're going to look at what this load button does and how we're building our screen based on state. So what we're seeing is the empty state. There's no users loaded, and we're not loading either. So while our documents is empty, we're not currently loading anything, so this is not built. But we don't have any users yet. We haven't clicked a thing. So what we're seeing is this no users loaded empty state sort of thing. So what we have here is a text button that calls load, and what it's going to do is go context.read with the generic type. It's going to look up that user's block, and we're going to use add. Add is the method that we're going to call in the block to dispatch an event. And then we're going to have to give it a new instance of a user's event. In this case, a user's load all event that doesn't need anything. But yeah, it just needs an instance of one of those event classes. So when we tap that, it's going to load from Firestore, and we should see our guy that we already have existing in Firestore. There's two of them actually, but yeah, they're there. Okay, so loading is working great, and you saw the loading screen really briefly there. Firestore is really fast, so these loading states do not happen for very long. I think that you could even consider not showing loading and just letting it pop in when it's ready. This Firestore works so incredibly fast. So yeah, now that we have some users though, what we have is a listview.builder, and each one of them gets mapped to a user list tile. So that's in the components folder, and it just puts their email and a raw unformatted date. I didn't bother date formatting here. And then it has a button which will delete them. So just like here where we're dispatching that event with load all, it's going to dispatch a delete event with their ID. Okay, let's look at the floating action buttons for the add user. So we have a floating action buttons, and they're actually in a row, and they need the current state. So here we have the query users button. It's going to be covered in the next tutorial when we query and figure out how we can actually get users that satisfy a certain condition. So we're just going to skip to add user. So add user shows a more horizontal when it's loading, and otherwise it shows an icons.add. Some users there. That looked a little weird, sorry. And if we restart the app and load them again, then they would come from Firestore. So let's look at Firestore again and just see, okay, there's a whole bunch of new documents there with all the different users that I added. And the way that I'm adding them is through this method here, create random user. So it just picks a number between 0 and 50, or 1 and 50, I think 0 and 50. And then it dispatches this event, users create event, with the name, the phone number, that's not actually a phone number, and the email, that's obviously not an email either. And then the birth date is just that random number is the number of years old they are. So it's now minus that. So yeah, the birth date 1990, 1984, stuff like that. Okay, so let's look at, instead of this screen, let's look at that list tile. So that is right here. So the user list tile needs a user, and it's just a list tile that displays some stuff. The is3 line gives a little more padding for when there's lots of text. So it's got the user.name, the email, and the birth date. This is unformatted, so it's just the raw date time. And then on pressed, it calls delete. So each delete is split up by the ID of the user, right? So if I delete this one, that one loads independently of other ones, which means I can spam this and have multiple deletes going at the same time. Now deleting in Firestore is also super fast, so it's hard to even see it loading. And then if we go to Firestore, we've deleted a whole bunch of documents. Now it looks like my app actually doesn't know of all of them that exist right now in state. So if we hit load, it actually seems like there's a couple still kicking around, and we can delete those. Now when we hit load, there's nothing, and there's nothing in Firestore. Right, so again, just another reminder that if somebody put delete where true or delete a whole collection, it will go through if you're in sandbox mode and delete all of your stuff. So before you actually release your app or even have a beta test, you probably want to put up some Firestore rules to control who can and can't delete that, which is again going to be the content of a tutorial soon. And I'm thinking that to use Firebase storage, which is a file storage, we're going to go to a full page view of the user profile, and maybe we'll let us choose a file from the phone or take a new photo and put it into make a thumbnail size and stuff like that to use photos and file storage in Firebase in a future tutorial. Okay, so I hope you guys enjoyed. The next one is going to have some queries, and then shortly after that we're going to do some file storage as well.